finishing up the last couple of formulas that we had from class that we just didn't get to yet. We have trapezoid, so 1/2 height times base 1 plus base 2, or the height times the mid-segment. So if you have a mid-segment, all you do is multiply that by the height. Now, in something like a trapezoid like this, remembering that your height is your perpendicular, so straight up and down, and your height always connects your bases, and in a trapezoid, your bases are your parallel sides, so the 8 and the 20. The example that I want you to do from what I gave you in class is number 2. And you'll notice that here are our parallel sides. Remember, your triangles here mean parallel. So this could be base 1 and this could be base 2. Out here is your height. And the reason is because it connects one base to the other base at a perpendicular intersection. And so it doesn't matter that it's on the outside, because even if you threw it in here, it would still be a distance of 10 between the two bases. So your area is 1/2 the height times base 1 plus base 2, which gives you 1/2 times 10, and add your bases 15 and 12. And you can type that entire thing in the calculator. You don't have to do any of it by hand, and you will get that your area is 135. All right, then if you go on down to number 9, whoops, ignore that, sorry. All right, if you go up to number 9, you'll notice that this one is also a trapezoid because it has one pair of parallel sides. Now, this is marked as 6. Well, that being 6 would mean from this base to this base is a distance of 6, which means that's really this side over here, right? And that is your height, because it's your distance between your bases. So when you go to plug it in, 1/2 height times base 1. Oh no, I'm out of room. All right, hang on. I'm moving it over here. Sorry. Let me cover some stuff up. That's not helpful. All right, hang on. There we go. So if we go and connect these to the area, 1/2 height, base 1 plus base 2, so we end up with 1/2. The height is 6, and our bases are our parallel sides, so 12 plus 8. And when you plug that into your calculator and calculate your answer, you will get a total of 60. Now, for another example or another area formula is the circle. And we've done area of circles before. It's not even new by any means. We did this earlier in the year. And I really only have the one problem to show you for the circle. So area is pi r squared, r being the radius. Now, when you look at number 8, so let me scroll over here and get number 8 in the way. All right, let me cover this up now. When you look at number 8, you'll notice that you have two different shapes here. We've got the circle and we've got our square on the outside. Well, we know that to get the area of the square, so area of the square, and I'm just going to draw it because why not? You know what I mean. Area of the square. All right, and then we have the area of our circle, and that is pi r squared. Well, if you're looking at the side length of this square, you could say it's connecting this point, right? So from here to here to here, it's that same distance. So from here straight across is 10, which means that's the diameter of the circle. So if the diameter is 10, then the radius is 5. So to find the area of the square, we take 10 and we square it. So our area of our square is 100. The area of the circle, so this is the square, the area of the circle is pi r squared, which would be pi times 5 squared. So I'm going to leave that as 25 pi. I'm not going to actually multiply pi into the answer yet. But to get this area out here that's shaded in and nothing else, we have to take our square area and subtract our circle area from it, so 25 pi. And then that gives you 21.46 as your area. All right, and then your last area formula that you have is for a sector. And a sector means just a piece of a circle, so this shaded area here. So what you're going to do is take your area, and this means the area of the sector, okay? So this will be our variable. Put it over the area of the whole circle, and then set it equal to the degree of the arc, and put that over 360. So it's kind of like doing the arc length. And the problem that I have here is number 10. And let me just cover this up, get that out of the way, and look at number 10. So if we're looking for the shaded area, well, AD is a diameter, right? So this is a diameter. So if that's a diameter, this is 75, that makes this 105, which also makes this over here 105. Okay, so it is the area over pi r squared equal to degree over 360. So the area is what we're looking for, x, over pi r squared, which is 11 in this case, equals the degree measurement. Well, if we're looking for this whole thing, this whole arc here is 105, and this whole arc over here is also 105, because those are central angles. So that's a total of 210 degrees out of a total of 360. So we do our cross multiplying, 360x equals, and when we multiply the other numbers, we get a really large number, which is 25,410 times pi, and then we divide by 360 to get that your x, which is your area, is 221.74, and that would be your area of just those little sections.